Mike Townsend. I'm the precision machining teacher here at Pecos Technical College, and I'm going to let you know a little bit about my program here. It's a 2-year program, and they come into the program and they can learn the basics about machining, how to run lathes and mills, and then we start working on the CNCs as soon as possible, and it stands for Computer Numerical Control, and that's where they work the computers and AutoCAD and CAD design stuff, and then they can move on to different jobs after that in the aerospace and engineering fields. Almost everything you go out and buy, whether that's a part or a part for your computer or a part for a bicycle or a motorcycle, there's usually a machinist at one time that has their hand in something that they make. When they learn new things, I try to sneak it into them so they're learning at a pace that's pretty fast, but the advantage we have over a typical math class or academic class is that we have hands-on, so they can get out in the shop and they can actually take what they've learned in the classroom and apply it to something that's real that they can touch and feel.
I'm Shelton Reed, and this is the Pickens Tech. It's the machining program. It's precision machining, and here we learn about all of our measurements and mathematics for making precision machine products on lathes and mills and CNC machines. And with the CNC machines, they're computer ran, so we write all our programs in G code. We put them over on the machine, and we design our product in a program called SolidWorks.
My name is Landon McKenna. I am a senior in high school, and this class is precision machining. Right now I'm on SolidWorks. This is a 3-dimensional computer program that we can do to put on the CNCs, lathes, and mills and get blueprints. And right now I'm trying to put a skeleton key on here. I'm going to make it probably on one of the CNCs.
Alright, so this is the lathe. This is all your feeds and speeds for how fast your chuck is turning and how fast it's moving down the part. That way you can get a better surface finish, and you can also use the feeds for your coarse or fine threads if you need to put threads on a part, internal or external threading. Right now I'm actually working on a flywheel for a small motor, and I'm just turning down some radiuses on it, putting some relief cuts and doing things like that. You have your chuck, and this is what holds the part. And then you have your lathe tool, and this is your lathe tool is actually what cuts the steel or the aluminum, whatever you're working with. There's various kind of lathe tools like this. This is a carbide, or there's just high-speed steel, which is what I'm using right now. Depending on what you're using, if it's really hard steel or stainless steel, you might need to use a carbide or a stronger tool. Or if it's aluminum, usually you can get away with an aluminum or something like that. You can get away with a regular high-speed steel.
We've got a pretty high rate of students that get into jobs after they get through the program here. It's probably in about 85% range.
A lot of different job options for custom car building and custom bike building and stuff like that.
I'm going to go to the military, probably the Army or the Air Force. More specifically a weapons engineer in the Army.
You can start moving up and working with the engineers and design mechanics after that, and then those jobs go up into the $25 to $50, $75 range if you get in with the right company.